Okay, today we're going to do something which is presumably review, which is flow control. So because it's review, we're going to just kind of go through them all. Flow control is basically just how you direct things. So they're conditional things, the if-else, the switch statement, which came about because people got tired of doing lengthy if-else things. And we'll kind of look at some of the issues with that. The ternary operator, are you familiar with that? You know what ternary means three. You've probably seen it, but if you haven't, then you will after today. And then while and do-while loops, you're familiar with that, I hope. And then the for loop. So after this, in Java, you've done all this before, but write a conditional branch forming each form of if. There are a number of different possibilities. The switch statement, which is very useful. This ternary operator thing, again, that's it's a little bit of syntactic sugar, as it were, but it's kind of nice in certain settings. And then the difference, understand the difference between a while and a do while. Those and basically how to construct them. Okay, so you've all seen, anybody not used an if statement before? So you all have. So the idea is that you have if and then a Boolean condition, and then and what follows is a block. Now, kind of in a way going back to C, in order to save a few keystrokes, it's possible to omit the curly braces if you have only one line. Never do that. That's very bad form. Why? Because it can lead to code that looks different than the way it behaves. So if you have an if statement that has only one line, if the condition is true, then you can leave the curly braces off, and that may be, in some books, they even give examples like that. Why? To kind of save a little bit of typing. Do you see what the problem is? The problem with that is that if you have two lines, so let's say I have two lines that I want to execute in the conditional, and I don't put the curly brace in, what will happen is it will only execute the first line under the condition, and it will always execute the second line, and that isn't what you want. In other words, what the code looks like is different, and in fact, you may even indent it to look like that's what you're supposed to do. And especially if you come from Python, you're kind of used to indenting things to make it look like that's what the intent is. But in Java, white space doesn't matter, and so the code looks different from what it actually does, and that's what's evil. That's why you should always use curly braces, even if you're only doing one block. So sometimes you want to execute some code only under a certain condition. That's when you'd use the first form. Sometimes you want to do one or another, and that's when you use the second form, if else. So if condition one, then you do one thing, otherwise you do the other. So you're always going to do one or the other. In the first case, I'm only going to execute, I may execute this or I may not. In this case, I'm always going to execute either this one or this one. And you can chain them together. If I have three options, I can say if condition, then this, else if, and you can chain those pretty much forever. Question?
Sir, I'm guessing not, but is the first case sensitive for the if statement?
Oh, you're saying that? Yeah, that's yeah. PowerPoint automatically capitalizes things. Yeah, thanks for catching that. That should be a lowercase. Thank you. Yeah, Java is case sensitive. Evidently, Clippy is still alive and well, but hidden. And, oh, that's right. You're too young to know about Clippy. Okay, so what goes into these Boolean conditions? You know, this is something you've all dealt with. Very typically, a lot of times we're comparing numbers. So we have relational operators, so we have less than, greater than, less than or equal to, greater than or equal to. So those are when I'm comparing numbers. We'll see an example of that in a little bit. And then equality operators, which these can be used with pretty much all data types, but with caution. So the double equal says they are literally the same, and then the bang equal or exclamation equal is not equal. So all of those are what are used in that Boolean expression. And as I was haranguing about strings, never use double equal for strings. Also, never use double equal to compare two double values. And do you know why? Do I have to go through that again, or? Okay, you got that. In other words, I can have if I do two computations that wind up in a double, and say, well, if they're equal, do something. The thing is, they could be mathematically equal, but on the digital computer they could be off by one bit way out in the far reaches, and then the double equal will fail. So when you're comparing doubles, you should always use like an epsilon, and say if the difference is less than epsilon, if the absolute value of the difference is less than some predetermined tolerance, then decide that they're equal. And you choose the tolerance in such a way, like 10 to the minus 10 or 2 to the minus 10 or something like that. Some very small number that. Okay, so. So examples. So like if temperature is an integer, you say, well, if it's equal to 100, not equal to. So here's a character. Remember, characters can be are treated as integers. We have less than or equal to. Yeah. So you're familiar with all these. Now, when we have, we can operate on Boolean expression. So each of those comparison things, like age bigger than 4, that evaluates to a Boolean. It evaluates to either true or false. And unlike in C, they decided that 0 was going to be false and non-zero was going to be true. And it seemed like a good idea at the time, and it was a terrible idea. So Java fixed that. Okay, so we can combine Boolean using the Boolean operators. So the double AND means that if both Boolean expressions are true, then it's true, and if one of them is false, then the whole thing is false. So you've seen those truth tables, right? Okay, so you're all, and then the double AND. Now make sure it's a double AND and not a single AND. A single AND is going to do bitwise comparison, and that's something that, how should I say, is like, Java does that, and in a lot of times in certain numerical methods, they play with bit stuff to make, because it's really fast. However, one of the reasons why we're in an object-oriented language such as Java is that we're operating at a high level. And if you're doing bitwise operations, that's at a very low level. And in other words, if you're doing bitwise operations, then in Java, then there's a mismatch between the tool and the task. If you're doing bitwise operations, you want to use a lower level language, like C, for example. So but just be careful, because if you put a single ampersand, then sometimes Java will think that you're doing bitwise stuff. Syntactically, it may actually work. So if I have a single and I have integers that I'm comparing, it'll do bitwise stuff. and not what I'm really trying to do. Okay, the or is the double pipe here. And then the not, as we've seen, is the exclamation point, or bang, as it's called. So if I have an expression that's true, and I put the exclamation point in front of it, it'll turn it to false. And likewise, the or is, if I have two Boolean expressions, if one of them is true, it's true. If they're both false, then it's false. That's okay. So here's just an example of kind of using some of this, and then I'm going to introduce you to the random class that we'll talk about a little bit more in subsequent things. But Java has this kind of cool class called random. Actually, the textbook, for whatever reason, doesn't kind of delve into it as deeply as it could. But all right, so we're going to flip a coin. So how do you flip a coin? Well, we're going to assume it's a fair coin. So in a fair coin, it's either heads or tails, and it's going to be one with probability, each one with probability half. So that's what we're going to do. And let me switch to NetBeans here. Where did you go? Is this you? No, there you are. Okay, so now I also want to show you how to pull from in this particular case. What's on GitLab is actually ahead of what is on my computer. Why? Because I added some stuff on another computer and pushed it to GitLab. And so now there's kind of there's stuff there that isn't here. So how do I reconcile that? And that's where the pull comes in. So what I do is I always do this at the top of the project. I can right click, I do git remote pull. Okay, not clone, pull. Clone will try to do something different. Okay, so now, again, remember here's that blue U. That means it's going to update what's happening locally. And when it's all said and done, we notice that there are a few more classes here that weren't there before. That they were just pulled down from GitLab. So what I'm looking at here is the coin toss. So there is this neat class called random. It's in the java.util package. And so if I'm just kind of using it plain, I need to import it. Here's kind of a little trick as well. Supposing I just kind of type this in. So I said I want to use random, and I know that that's a class somewhere, but it may not be in the right package. Now notice the red squiggly of death here. Okay, but when I hover on it, it says it can't find the symbol. So when it can't find a symbol, here's what you do. You just sort of right-click anywhere, and you say fix imports. And it will go out, and it went out, and it found random, and did the right import. So that's kind of, okay, so what is this? Oh, so this is a class. It just has a zero argument constructor. I'm going to create a new one. And it has a lot of neat methods, but one of the workhorses is something called next double. And what next double is it generates a uniform 0 to 1 random variable. And so I'm going to flip it, and that's going to come back with a uniform 0 to 1. And so if that value is bigger than a half, then I'm going to say it's heads, and if it's other else, tail. So here's an example. This is if else, and then I'll just sort of print the results. So I run the file, and in this case it came up heads. Now the way that this is done is this actually next quarter we'll kind of delve a little more deeply into how these pseudo random number generators work. You've probably used this you've used computer generated random numbers before, right? Okay, so and just the thing to remember about that is that it's a lie. There is no such thing as a truly random generator from the computer on a finite algorithm. But it passes what I call the duck test. It kind of looks and talks and quacks like a random number generator, and so it's kind of good enough for government work. So if we run it again, okay, came up heads again. If we kind of run it enough, okay, it came up tails. So we're seeing both of those right there. Okay, so there's an example of an if-else. Now, what happened is kind of back in the Jurassic age of computer programming is they had this sort of string of if else, and so they came up with the idea of, well, instead of doing that, let's kind of lay it out in a way which is more conducive to expressing what the intent is. And so the book has this kind of cute example of this dice man thing. I hadn't heard of this before, but evidently the story is this guy who kind of rolls a die every time he tries to make a life decision or something like that. So, okay, so there's an example of a switch statement. So presumably this would be the roll of a die between like 1 and 6, and so you say switch, and then the switch in parentheses, and then what follows is a block. Okay, everything in a curly brace is a block. So the block has case, so you look at all the different possible cases. In this case, there will be 6, and then now it's optional to have a default in your switch statement. You've all done switch statements before, right? Okay, so you should always have a default, even if there's no possibility. I mean, I've written switch statements where the default is this should never happen, and of course you run it and it happens. So it's like, okay, what the heck happened? Okay, so you're all familiar with that. So let's look at an example of that. Okay, here's the dice man thing, and again we're going to use random again, and for some reason the book didn't do it the way, or they did it in kind of a clunky way, but there's kind of a neater way. So so here we instantiate our random. Here I'm doing it on one line. Why do I do it on 2 lines like this? Especially in the beginning, I really want to emphasize that there are 2 things going on. Like in this line, there are 2 things going on. One is you're declaring this random lowercase variable to be of type random. It's an object reference of type random. And this part instantiates a random using the default constructor and then assigns that object to this variable, or strictly speaking, the object reference to that variable. So there are 2 things going on, and they're very, very different things. And the thing is that if all you see are these, you sort of get the impression, whether consciously or subconsciously, that this is all one thing. But it's actually 2 things, and that's why I kind of do it this way, until you kind of get that. And a lot of times it's just to remind me that that's what's going on. Okay, so here I'm declaring instruction to be a variable of type string. Now there are a number of different ways of doing this. What the book does is the book uses this sort of next double thing and says, okay, that's a value between 0 and 1, then it multiplies it by 6 and then turns it back into an int. And you can do it that way, However, random has a method, has a neat method. It's called nextInt, which is heavily overloaded. Subsequently, we'll talk about what overloading is about. But nextInt, if I give it an argument, in this case 1 to 7, what that does is that will generate integers between 1 and 6. So what this is called, the term that Java uses, or in fact, let's look at the Java doc for this. Okay, where is it? Okay, here it is. Next int, origin and bound. And when we, where are we here? Next. Where'd it go? Kind of loud. Am I going crazy, or did it disappear? Is it the bottom? Oh, there it is. Okay, there we go. Okay, okay, yeah, as you see, there are various versions of this. So, calls origin and bound, and we can read a pseudonym shows an int value between the specified origin inclusive and the specified bound exclusive. So what that means is if I give it 1 to 7, if I say 1 to 6, it will only go up to 5 because it said the bound was exclusive. Still recording, I hope. Okay. All right. Okay, so this will generate integers between 1 and 6. And so now if I do a switch on it, and here are all the different cases, and and see what could go wrong. Well, what could go wrong is maybe I kind of screwed this up. Well, let me do it the right way first. Okay, so let's run it. Okay, so it says do what Arlene says. That meant it came up 3. If I roll it again, follow your emotions. Okay, so it's getting the different things. Now, what could kind of go wrong? Well, if I screw this up, then not a valid throw. Okay, so if I get that, I'm going, okay, well, something went wrong there. I'm not generating the right values. And then now, one of the nice things about NetBeans and Git is that notice that there's like kind of a little blue thing. So blue is kind of the hint that something has changed. So it says one line has changed. It actually shows what the previous one is. And so if I click on that and just do a reversal there, then it goes back to what I had before. Okay, so that's the switch statement, and then there is a couple things to understand. Notice that there's a break after each and every one. If you don't put the break in, what happens is it falls down to the next one. In other words, if the break is not there, it will continue to the next case. And that's sort of it's a how should I say it's a little too easy to forget the break, and so they said, okay, well, here's this kind of alternate syntax which makes it less likely to forget the break. So in this particular case, this is useful if the switch statement is going to return a value in this. And actually NetBeans kind of helps a bit with this because it actually, okay, and notice, if you've noticed that occasionally there'll be these little light bulbs. Okay, a light bulb is, NetBeans has an idea. And if you kind of hover on it, it'll give you what it's thinking. And in this case, it's thinking it convert to switch expression. Okay, so what happens if we do that? Well, all of a sudden, we're now using this form of it. And it just kind of does it for you. So one of the great, the things about an IDE is that it really, it's not that it's saving you any typing. it's being more, it's gonna do things right. I mean, if I have to type something, the chances of me screwing it up are bigger than one, or bigger than zero, less than one. Probabilities are always less than one. But when NetBeans does it for me, they, so far, have always done it right. Okay, so that's, you know, and this is a matter of taste. To be honest, I've kind of flipped back and forth. I mean, I try not to be a kind of a curmudgeon about some of these things, because that's the way we did it and we liked it. So to me, this, well, just in terms of looking at things, if you know what a switch statement is, you kind of get this. This takes up a lot of real estate. And if I look at this is much more compact, and to me, this conveys what the heck this is doing in a much cleaner way. So, and your mileage may vary on this. So whatever you prefer. Okay, so what can we switch on? And there are only 4 things that we can switch on. You can't switch on an arbitrary thing. We can switch on ints. You can't switch on doubles. We can't even switch on booleans. It would be nice to switch on booleans, but we can't. Why? Because with a boolean, if it really doesn't make any sense, you know. So like have a boolean expression. There are occasionally there's some situations where I might have multiple Boolean conditions, and I want to kind of do a switch on that. And actually, I think Visual Basic lets you do stuff like that. So that's one that's one point in Visual Basic's favor, which it really needs, because it's otherwise pretty awful. Anyway, but in Java, you can do ints, you can do characters, because characters are like ints. You can do it on strings, and we can do it on something called an enum, which we're going to cover a little later this week, you know, what an enum is.
So what would be the benefit of having a switch statement or boolean anyway? You know, just basically anything else?
Well, for me, the benefit would be if I have a lot of different numerical conditions. So let's say I have a range of values, and so let's say I have 5 different range of values, and I want to do 5 different things. So if I could do a switch on, you know, if this number is between this and that, or if it's between this and that, or this and that, that would be kind of nice. I can't do it here. I can actually do it in Visual Basic, as it turns out, but you know, that's only come up, you know, in the past 20 years. That's come up for me maybe 2 or 3 times. So, but yeah, normally there's a good reason not to kind of do that. Because why? Because, well, I don't know. Actually, they could do it. Yeah.
So when you say legal type to switch on, that's specifically for like the different cases.
Yeah, but both the cases and. Go back here. So when I say switch this, you're here, like what can go here? What can go here is an int, a char, a string, or an enum. That's what. And then now these cases have to be concrete. They can't be an expression. You know, that would be kind of nice, but this is the only way to do it. In other words, this is an int whose value can only be 1 or 6, and I have to kind of explicitly lay those out.
Okay, so you can do like case less than 4. You can have a case where it's just less than 4.
Oh yeah, exactly. Yeah, correct. So now, if I wanted to do that, what I would do is, if I wanted to say, if it's going to be less than 4. I would have case 1, case 2, case 3, and then, but not do a break. In other words, I would say case 1, not have the break. Case 2, not have the break. Case 3, etc. Now here, actually with this syntax, what I can do is and I don't do it that often, but I can say case 1, comma 2, comma 3 to enumerate the possibilities. And yes.
So, just to reiterate again, that has to be hard-coded, for lack of a better phrase?
Yes.
Okay.
Yeah, the cases have to be hard-coded.
Yeah, makes sense.
That's. Okay, so here, this is the ternary operator. Ternary means 3. And this has sort of 3 things. And have you seen this before? No, you have. Okay, so what you have is you have a Boolean expression, and then the question mark, option 1 or option 2. So in other words, if the expression comes out true, then you do this, otherwise you do that. And it's just some syntactic sugar for certain things. I find it useful for a handful of situations. It's not really totally necessary because you can always have it like an if-else for this. It's exactly the same. My main use cases for this are when I want to kind of just be really lazy and put everything on one line. So here, x would be some integer. And what this is saying is when I modulo it on 2, if that's equal to 0, then I'm going to say it's even. Otherwise, I'm going to say it's odd. Now, actually, my critique of this is that I would put the parentheses here, even though it's not necessary. Why? It's not necessary because the modulo operator binds more tightly than the equality. But nevertheless, this should have parentheses. Okay, so that's a ternary operator. Yeah, so this is all kind of review. Okay, finally, iteration. So there are 3 versions of iteration. The for loop, the while loop, and the do while loop. So this is the syntax. So the for loop is, this was kind of the weirdest one for me. And let's see, I think, I'm trying to remember if now Python doesn't even do anything like this. I mean, it has something similar, but it doesn't have this particular syntax. This is from C. C kind of came up with this thing. So the idea of this is you initialize stuff, you test it, and then you increment. And they're all actually optional. So this is actually a legal statement, and this will produce an infinite loop. In other words, you're not initializing anything, you're not testing anything, and you're not incrementing anything. The main use of this is, there are 2 main uses. One is when I have either an array or a container. We'll see what a container is later in the course. And I just want to iterate over every single one. I can just kind of buzz through them. The second main use case is when I am working with an array and I want to, I need to access the particular index. In other words, I want to loop over an array and I want to, I need to know what the index is. The while I use when I don't know how many times I'm going to do it. So if I have an array of size 10 and I want to loop over that whole array and I want the indices, then the appropriate use is a for loop, because I use a for loop when I know how many I'm going to be doing. When you know how many steps there are going to be. The while is I don't know how many times it's going to be, but I know the condition in which it's going to finish. So now you you can express the same logic in each one of these with a few caveats. The do while says, I'm going to execute this block while a certain condition is true. And it's important to understand the difference between a while and a do while, and there's only one in addition to the syntax. The while loop, because it tests first, if it tests and it comes up, if the test comes up false, it doesn't execute at all. So it tests, and if the test comes up false, then it skips it altogether. In the do while, it executes the block first and then tests at the end. And so a while loop will execute 0 or more times, a do while will execute 1 or more times. So the difference is that when you want to execute something and you don't know if you even want to do it once, then use a while loop. If you want to make sure you execute it at least once, then use a do while. Okay, so for loop is kind of it's kind of the workhorse of this, and we use it typically when the number of iterations is known in advance. And this is one of the things, the places where Java is really kind of made a small but significant improvement over C, and that is remember that arrays are objects, and as objects, one of their attributes is something called length. So that relies on a couple of things. One is that arrays cannot be modified. The size of an array cannot be modified. If I declare an array of a certain size, then it's that size now and forever, that particular one. And so it knows what its length is. In previous languages, I would have to have another variable that said, okay, if I have an array of length 10, I have another variable and I have to set that variable to the length of the array because the array didn't know how long it was. And so, of course, anytime you have two pieces of information that have to be the same, Murphy's Law says they're going to get out of sync. So when you're, okay, that's one. The second thing is this. Notice that I'm declaring my index, my iterating variable, inside the for loop. And that's important for another reason, for another principle. The principle, and I think I've touched on this once before, but it bears repeating. All variables should be declared in the narrowest scope as possible. In other words, variables should only exist in the smallest region of your code as is possible. So what does that mean for this? This index, this variable I, only exists during the duration of one execution of this for loop. And once you exit that, the variable I this variable I doesn't exist. So what that means is that I can actually declare it again. So if I have another loop I'm going to do after this, I can use the same I again all over. But this is the value of this is that if I declare it outside, which I can do, I could declare this int I outside here, and then I don't declare it inside here. When it exits, that variable I still exists and is 1 greater than, it's that the value when this test failed. Okay, that produces all kinds of potential issues, which are completely eliminated when I do it this way. In other words, when I declare it completely within the block, then this variable only exists inside this block, nowhere else. Yes?
If you declared it outside, then if you run into some sort of issue while it's going through the loop, don't you use like a break condition to break out of
Correct, yes. And now, and sometimes there are situations that where you might want to do that. So, for example, I might want to say, at one, I have an array of numbers. What's the index of 5, say, if one exists? So, kind of loop through this, and then when I find that index, I want to jump out. So what you could kind of save a variable by declaring this outside and then kind of having it jump out. A better way would be declare a separate variable that would say, this is the, index of 5, initialize it outside, and then do the break. Again, like break. Thanks for mentioning break. I'll circle back to it. And then that variable would be it instead of the looping one. And the reason for that is because you want your variables to be sort of single purpose. That is, the purpose of this variable is to iterate over the array. The purpose of that other variable that you're mentioning is to identify which index in the array is a particular one. So and those are two different functions. And so, yeah, and would it be the worst thing in the world to do it, what you're suggesting? Absolutely not. But it just, but what you're, okay, in all of these loops, you can break out, and you all know that. So here's an example of a while loop, and this is, once we start reading from files, we're going to be using something like this. So let's say we're reading from some stream somewhere, and what it's supposed to do, it's supposed to be giving us a stream of integers, let's say, but we don't know how many there are. Okay, so a for loop wouldn't work because I need, it's a catch-20. I need to know how many integers are going to be in this stream if I want to use a for loop. So a while loop, okay. What's the test? Well, my scanner is going to say if I have a next, or I actually it has next int would be nice, but I don't think. Okay, while it has next, I'm going to give it a next int. And then as soon as it doesn't have one, then it will continue from there. So here's an example of the do while. So again, the do while always executes at least once. So in this case, I want to generate a random number until I find one that's a multiple of 3. Why? Who knows? But okay, and so I don't know what that value is going to be. It could be actually in this case. This is another. This will generate values from 0 to 999. And so I want to execute it at least once because I need to get at least one, but I'll generate the first one. Let's say the first one comes up 25. So is 25 a multiple of 3? Nope, it'll generate another one. Let's say the next one is 52. Nope. Next one is 48. Yep, and then bounce out. Okay, yeah, so now here's an example that kind of puts a lot of these together. Okay, so we're going to flip a coin here. We're going to, so here, and this is an example of how how should I say, like, in modern computers, there's lots of room, and so having extra variables is not a big problem. Okay, so here I want to say, this is how many times I'm going to flip it. Let's see, what is it, 100,000? Okay. And what I want to do is I want to flip it and I want to estimate the probability of heads. So here this is going to count the number of heads. Now in this case I know how many I'm going to do. I'm going to have the number of flips. And so 0, less than, and then increment. So here's the flip. And here I'm going to use the ternary operator. or just to, and so I'm going to increase the number of heads. If the flip is bigger than 0.5, I'm going to add 1, and if it's not, I'm going to add 0. And so this will count the number of heads. And then after this, now I need to be a little careful here because the number of heads and the number of flips are both integers. The estimate of the probability is the number of heads over the number of flips. And so that's an integer divide, so one way is to cast at least one of them into a double, and that'll turn the whole expression into a double. So if I run this, okay, the estimate is like 0.49825, whatever. So if I run it again, I'll get a slightly different one. But, you know, again, it's pseudo-random, so I'm going to get a slightly different one each time. Actually, if I if I give this number a seed, I'm going to get the, here just to kind of peek ahead. If I give it a seed like this, I'm going to get the same result every time. And here, I'll show you. 0.4991. I'm going to run it again. It's always going to be 0.4991. Okay, why? Because the pseudo-random numbers they're not really random. They kind of use a chaotic algorithm to kind of appear random. And okay, yeah, one last little Git thing that I can do. Okay, so here I've made a number of, notice the number of edits. You see the blue that says that I've edited these things. So let's say you've edited some stuff and you decide, well, no, I don't like it. What I can do is if I right-click on the name of the thing, I can say Git, revert modifications. It'll kind of come up and say yes, okay, so now it just goes back to where it was. So now your mileage may vary on this, but I know there have been many times when I've been sitting, I'd code for about an hour and realize this whole thing is just a bunch of crap. I want to go back to the way it was when I started. And has that ever happened to you where it's like and then all of a sudden it's like, oh, how do I undo all of this? Well, Git rides to the rescue here in this sense, is that I can always go back. And in fact, even if there are pieces, if you notice, I can actually undo certain pieces of it if I don't like what I've done. I mean, that is a real game changer, for me at least, because I've never been able to actually, before this, I was never able to actually put it back to the way it really was in the beginning, so.
So I'm guessing that beginning is right before when you saved it?
Yeah.
If you save it between words, it just goes up to.
Yeah, or in fact, in NetBeans, you can have a sort of an automatic save on that you're gonna, so it's, but Git is a lifesaver in this, absolutely, Okay, the last sort of, there's this, it's called for each, but you still use the for thing. So when you have an array, our first use of it is if there's an array, instead of, if I just want to loop over the whole thing, then I can kind of do this, and this is, it's not just, it is some syntactic sugar, it's saving some typing, but it's also a little more clear. Here it's clear what I'm doing. And I can also use this in the context of like what you were doing before. So for example, supposing I wanted to go through all these until I found George. Okay, so for each one I would test it for George and then ideally have a variable out here that says, okay, here's the name, who's George, and then whatever. But I wouldn't know what index it was. So if I wanted to know what index was George, then I have to do it the previous way. Okay, so those are the control structures. It's all mostly review. There are a few little ways that Java does things that are a little bit different than what you may be used to. Conceptually, there's nothing new here. You've all done this before. You know what all these things do, the control structures, the Boolean statements, the switches, and all that. But now you know how to do it in Java. Okay, and that is it for today. So next, start reading the next chapter. And I will see you then.